Okay, looking at factoring by grouping, okay, we have, just as an example, okay, we have the trinomial 12x squared minus 13x plus 3. And now, in the case of taking the factoring by grouping approach, again, you're going to initiate by multiplying the first and the last coefficients. Okay, so we have 12 and 3, and if we multiply together, okay, so we have 12 times 3 is 36. Now, we're looking at, in the strategy, we're going to split up the minus 13x, and we're going to form a couple of x terms that will be simultaneously factors of 36, and that will add up to negative 13. So, once again, for the factors of 36 that we're looking for, and again, we just formed 36 multiplying out 12 and 3. And of course, 12 and 3 will not add up to negative 13. Instead, we have the sum to be 15. Now, in terms of the combination that will add up to negative 13, both factors had to be negative. And it doesn't really matter what order you place them. But the factors we do have at negative 9 and negative 4. And both of these constants will add up to negative 13. So just taking what we have here with 12x squared minus 13x plus 3. So we have taking these factors and forming x terms upon splitting the minus 13x. And it doesn't matter which one goes at the front. It could be negative 4x or negative 9x. And then looking at grouping. Okay, so we have with the first two terms. Okay, so we have 12x squared minus 9x. Okay. Now we have the middle operation to be subtraction. And if I were to factor, let's say, out the subtraction, or the same as factoring out negative 1. So you have a negative into negative 4x will go 4x times, and a negative into a positive 3 is going to be minus 3. Okay, and so we have again, so if you were to remove the parentheses, you still have 12x squared minus 9x minus 4x and minus negative 3, which is still the addition of 3. And we have, with the pairs, if we take the greatest common factors, now we have variable terms in x with the first two items, and the greatest common factor that will go into both 12x squared and negative 9x, okay, that will be 3x. And for 3x into 12x squared, okay, we have it 4x. 3x into negative 9x, okay, we have it negative 3. And I will just bring down the subtraction here. Now for 4x minus 3. Now, we're not going to have an x term since we have in the pairing the minus 3 to be a constant. And so the greatest common factor will be the highest number that will go into both 4 and negative 3. So that is going to be 1. And that's going to be placed alongside the subtraction. And 1 will go into 4x minus 3. 4x minus 3 times. And so for what we have in factoring, okay, we have shared from the groups, we have 4x minus 3. And the other factor will arise from the greatest common factor terms and joining operation. And so in this case, we have 3x minus 1. And once again, you can always go back and check. 4x times 3x is 12x squared. And we have 4x times negative 1 is negative 4x. Negative 3 times 3x is negative 9x. And again, a negative 4x and a negative 9x will make negative 13x. And negative 3 times negative 1 is a positive 3. Okay. And so that will be the combination that we have here. All right. Now, looking into the exercises, okay, from page 41, and we have 4 terms in the mix. Now the proportions of the terms and the coefficients, okay, will be such that we can factor by grouping. And so we have for number 77. Okay, we have 4 terms. Okay, so we have 8ax plus 18a and we have plus 20x plus 45. Okay, now we'll be able to factor by grouping, okay, without having to split any terms, because it's going to turn out that we'll be able to group together the first 2 terms as well as the last 2 terms. And the reason I can do this is that the variables and coefficients are aligned such that the proportion between the second and first coefficients will be the same as the last and the third. Like for instance, we have 18 to 8 is a 9 to 4 ratio, and guess what? 45 to 20 is also a 9 to 4 ratio. And if I had, something like if I had 8ax plus 18a plus 20x plus, let's say, 43, I would not be able to do factor by grouping and operate in line with what we have been looking at. Now, but because I have a 9 to 4 ratio between the second and first as well as the fourth to third constants, and because I have the variables aligned such that I can factor by grouping. Okay, so we have for 8ax plus 18a. Then we have this as the first group, and then I have the operation of addition in the middle, and then just putting 20x plus 45. Now there's no sign change like what there was earlier, like going from negative 4x plus 3 to 4x minus 3 in parentheses, because that instance had subtraction in the middle. This operation that we have in the middle is addition. So no sign changes called for once we insert the parentheses. Okay, now crossing over to drawing out the greatest common factors. Now we have with 8ax and 18a. Okay, both of these have the letter a in common, and both 8 and 18 are even values, and so the greatest common factor is going to be 2a. And taking into 8ax plus 18a, so this would be 4x plus 9. And for 20x plus 45, now the highest term that will go into both 20x and 45, that's going to be the constant value 5. And 5 into 20x plus 45, okay, so that is going to be 4x plus 9. And we have a similar bit of history to repeat, where we have a common factor that is shared between the groups with 4x plus 9. And once again, the other factor will stem from combining the terms from the outside. Where we have, in this case, we have 2a plus 5. Okay, and so that will be the end result here. Okay. Now for the next item, okay, we have for number 87, and this problem. Okay, this one's a bit tedious because they have a bit of a twofold situation here. For we're going to have, in this particular trinomial, okay, we're going to have the greatest common factor to extract. So for what we have here, with 7y cubed z minus 40y squared z squared minus 12yz cubed. Now we are going to be looking at factoring out binomial or two-term expressions. But before we do this, okay, with the earlier examples, we didn't have to worry about this. But for what we have for this particular trio, among others, okay, there's the greatest common factor that you'll be looking at drawing out. Notice that all these terms have the letters y and z involved. And the greatest common factor, okay, you'll be looking at the lowest degrees of each of the common variables. So we have y, first order, and z we have a first order. And the highest constant that will go into 7, negative 40, and negative 12 is only going to be 1. So the greatest common factor we're going to have at yz. So for this particular trio, I'm going to factor out yz and yz into the first term. Okay, so this would be 7 y into y cubed is y squared. Okay, we already had the z taken care of. And then we have into the next term, we have negative 40, and we have y, z will go into z squared, z times. And for the last term, we have negative 12. Now y will go into itself one time, and then we have z into z cubed becomes z squared. So setting things up, okay, so we have part of the setup, okay, we have the greatest common factor, and for the rest of the factorization, this is going to stem from working with the trinomial that we've just factored. Okay, and so sort of moving to the side here. Okay, so we have again we have with the trinomial. So we have 7y squared minus 40yz minus 12z squared, and bit of history repeating. Okay, so looking at multiplying the first and the last coefficients. So you have a positive 7 and a negative 12. Now 7 times negative 12 is negative 84. And then we're going to turn around and find factors of negative 84 that will add up to minus 40. Okay. So again, we just dealt with 7 and negative 12, and those constants will add up to negative 5. Okay, but I want more of a punch in terms of the negativity that is created. So for these, we can say we have negative 42 and 2. Negative 42 times 2 is negative 84. Negative 42 plus 2 is negative 40. And these two constants will form yz terms upon splitting the negative 40 yz. Okay, so we have, in following through, it really doesn't matter what order you place the terms, but I generally like to go with having the positive to follow the negative wherever I can, especially when it comes to factoring by grouping. And so with that approach, we can have the operation of addition to be the central operation upon splitting up the middle term. And entering the phase of grouping. So we have 7 y squared minus 42 yz quantity. And again, we have the middle operation of addition. And we have plus the quantity of 2yz minus 12z squared. Okay, now in looking at drawing out once again the greatest common factors. Okay, so for the first, okay, we have 7y is the greatest common factor, and we have 7y times the quantity of y minus what's going to be 6z, and we have plus, and the greatest common factor of the second pair, that is going to be 2z. Again, 2z into 2yz, that's going to leave us with y. 2z into negative 12z squared, this would be negative 6z. If you notice, once again, we have a common binomial factor from the groups with y minus 6z this time around. And the other binomial factor will come from the outside terms, whereupon we have 7y plus 2z. Okay. And so we have for the final result here, yeah, yz, now I'll just do a little bit of color coding here. So you got yz times the quantity of y minus 6z. And we have times the quantity of 7y plus 2z. And there was quite a bit of work involved in this one. For you had a greatest common factor to once again extract, and then you still had the factoring by grouping with the trinomial remnant left over. Okay, so this one is a bit strung out. All right, now for the next item, okay, not so much work involved, okay, because here we have the expression in only a single letter, okay, and this is going to be where we have a squared trinomial. Okay, so you have, again, so you have p squared plus 8p plus 16. And if we factor, okay, so p squared, just as x squared goes to x and x, p squared goes to first order variables in p. Okay, so, and for 16, factors of 16, that will add up to 8. So we have positive 4 applied to both, and p plus 4 repeats, and so since we have repetition, it turns out that p squared plus 8p plus 16 is equal to p plus 4 raised to the second. Right. Now, for the next item, and this will be a combination of elements from number 87 and number 90. For we're going to have grouping involved, and also this problem is going to involve a square trinomial, okay, where we have different degrees here, and where we have more than one letter to work with. And in the case of number 94, okay, we have the variables m and n involved. And in this trinomial, so we have 9m to the 4th plus 42m squared n to the 4th. And we have plus 49 n to the 8th. Okay, and now this one we can factor by grouping. Thanks to the way the coefficients are, and thanks to the degrees in m and n. And let me mention, okay, so we have for the middle term, it'll have half the degree in the variable of what is on the outside, or at the front, and also what is at the end. So you have like m squared 1/2 the degree of m to the 4th, n to the 4th 1/2 the degree of n to the 8th. Just like over here, like in negative 40yz, y is 1/2 the degree of y squared, z is 1/2 the degree of z squared. Had I had any other degree like 7y cubed or negative 12z to the 4th or to the 5th, I would not be able to factor by grouping in this particular fashion. But with the way that the degrees are aligned as well as the coefficients, I can perform the grouping. All right, so we have starting out. Okay, now we do not have a greatest common factor to extract, and reason for this is that earlier, say for number 87, the variables y and z were shared throughout all three terms. But if you notice with the letters m and n, m is present only for the first two, and n is present only for the middle and last terms. Okay, and the highest number that we're going to, 9, 42, and 49, is only going to be 1. Okay, so I can go ahead and perform the factoring by grouping. So looking at what we have in the trinomial. Again, so if I multiply the first and the last coefficients, I have 9 times 49, so this will be 441. And looking for the factors of the product that will add up to the middle coefficient, 42. Okay, so we just dealt with 9 and 49, and 9 and 49 add up to 58. But again, I'm looking at those that will add up to 42. And 441, if I factor, 441 is going to be among the perfect squares. For 441 is going to be 21 times itself, and 21 plus 21 comes out to 42. And so it's going to follow that for what we have here. Okay, so I'm going to split up the 42 m squared into the 4th. So 21 m squared into the 4th plus itself. And then looking at factoring by grouping. Okay, so you had the middle operation to be addition. And looking at drawing out the greatest common factors. Okay, so we have with the first. Okay, so we have 3 will go into both 9 and 21, and we have m squared also factored in. So the greatest common factor here we have at 3m squared. And for the first group, so this will be 3m squared plus 7 into the 4th. And we have bringing down the addition. And for the last two terms, so we have 7. And in the variable n, we have into the 4th. And factoring, we have another 3m squared plus 7 into the 4th. Okay, so for that which is already revealed as common to both groups, we have 3m squared plus 7n to the fourth. And combining the outside terms, we have another 3m squared plus 7n to the fourth. Okay, and since we have an identity between the factors, okay, we have repetition. So this particular trinomial that we have in number 94, this will end up being the square 3m squared plus 7n to the fourth. Okay. All right. Now, in looking at what we have for the next phase. Okay. Now we've been working with two-term expressions, second-order expressions, and now we're going to make a bit of a transition, moving from working with squares of expressions to working with cubes. Okay, and this part you'll see fairly briefly in this chapter, but it will reappear later on, especially as we go into long division and synthetic division, and that will be in the second half of the course. Now, for sums and differences of cubes. Okay, now for the sum of cubes, they have a to the third plus b to the third. Now the factorization, then we have a two-term expression and a three-term expression. And the two-term expression is going to be basically the sum of the cubic roots of a to the third and b to the third. So you have a plus b. And the other factor, this will be a trinomial, and we have a squared minus ab plus b squared. And just taking as a bit of an example, say if you're working with the sum of cubes, and we'll say something like x to the third plus 64, and this expression is factorable. Okay, think of it like this. Okay, x cubed, that is the cube of x, and now b cubed is represented by 64. So if I'm looking at what it's going to represent b, it'll be that number times itself. That would give you 64. Now 64 would be the square of 8. Like 8 times 8 is 64. But in terms of cubes, 64 is going to be the cube of 4. Since 4 times 4 is 16 times 4 is 64. So 64 is going to be the cube of 4. Same thing of a is represented by x, b represented by 4. And if I carry over, we have a plus b. This will translate to x plus 4. And for a squared, this would be x squared. We have minus ab, so you have minus x times 4. Or by then you can just write this as minus 4x. And for plus b squared, this will be plus 4 squared. So we would have, in the follow-through, so you have the quantity of x plus 4 times that of what is going to be x squared minus 4x plus 16. Okay, so this is one sample, okay, of a sum of cubes. Now, in the case of what we have for the difference of cubes. Okay, so we have for a cubed minus b cubed. Okay, so for difference of cubes. Now, the binomial or two-term factor is going to be the difference of the cubic roots of a cubed and b cubed. So that'll be a minus b. Now for the trinomial factor, this is going to be entirely in terms of adding. So you have a squared plus ab plus b squared. And we can take, as an example, we'll say we have 27x cubed minus 8y cubed. Okay, now in terms of rewriting, okay, now 27x cubed, now that is a perfect cube, and that times itself will give you 27x cubed. Like the cubic root of 27 is 3, cubic root of x cubed is x. So you're looking at the cube of 3x, and you have minus. Now for 8y cubed, the number times itself will give you 8, that is going to be 2. And y cubed, that is going to be the cube of y. Okay. So in this one, we can look at a is represented by 3x, and b represented by 2y. And if I cross over to the threshold of factoring, so for a minus b, this would be 3x minus, okay, we have b, again represented by 2y. And then crossing over to the trinomial, so for the square of a, okay, what is a? That's going to be 3x. So we're looking at the square of 3x. You have plus ab, so you have, again, 3x times 2y. And for b squared, okay, so that's going to be the square of 2y. Now for what we have in the follow through, okay, so we still have 3x minus 2y. Okay, so we have the two-term factor, okay, that is already resolved. Okay, now for the trinomial, we have the square of 3x, where 3x times 3x, okay, this would be 9x squared. And 3x times 2y, this would be 6xy. And for the square of 2y, okay, so this is going to be 4y squared. And that would be the end result in terms of factoring this particular difference of cubes. Okay, now we have in the set, we have the numbers 102 and 106. Okay, so I have yet another change up in the variable. Now for 102, okay, we have u to the third plus 343. Okay, so we're looking at the sum of cubes, and in the particular layout, okay, so you can think of a cubed as u to the third, b cubed in reference to 343, and 343, okay, it's a number you probably don't see very often, but it happens to be a perfect cube, for it is going to be 7 times itself, So a is going to be represented by the letter u, b by the letter 7. So for the a plus b portion, we're going to have u plus 7. And for the trinomial, for a squared, you have u to the second. You have minus ab, so it'll be minus u times 7. And we have plus b squared, so you have b at 7. So you have 7 squared. And we have with the completion. It's going to turn out that for u to the third plus 343, this will be equal to the quantity of u plus 7 times that of u squared minus 7u plus 49. And on the side of what we have for the difference of cubes, okay, we have with 106. Okay, so you have another expression with raised coefficients and also exponents. Okay, whereupon we have 27m to the 12th minus 64n to the 9th. Okay, now both of these terms are perfect cubes. Okay, so once again we have like the cubic root of 27 is going to be 3. Now for m to the 12th, okay, now the cubic root of m to the 12th will be 1/3 the degree of m to the 12th, so that's going to be m to the 4th. And as for 64n to the 9th, cubic root of 64 is 4. Cubic root of n to the 9th, again, that's going to be 1/3 the degree of n to the 9th, so that's going to be n to the 3rd. So here we have a at 3m to the 4th, b at 4n cubed. As for the trinomial factor, okay, so you have for a squared, that's going to be the square of 3m to the 4th. And we have plus a times b, so you have plus the product of 3m to the 4th and 4n cubed. And for b squared, that is going to be the square of 4n cubed. All right. So we're going to have here, once again, the quantity of 3m to the 4th minus 4n cubed. And as for the trinomial, now we have the square of 3m to the 4th. 3 squared is 9. M to the 4th square will be the variable m raised to the 4 times 2. So we have 9m to the 8th. And we have plus, and we have 12. M to the 4th. N to the 3rd. And for 4n cubed squared, 4 squared is 16. And the square of n to the 3rd, that's going to be n to the 3 times 2. So that'll be n to the 6th. And that will be the factor result in this one. All right. And we'll be looking at other cases of factoring and looking at taking what we have and looking at working with factoring in one sense. But this will be in the case of dealing with fractions. I'll just call this part rational expressions and operations. And let's say that just as a case of working with rational expressions. This little something at somewhat an introductory level. Say we got 3/4 plus 7/8, and you're looking at adding together. Now again, to be able to add fractions, they must have the same denominator or bottom number. And here we have 4 on the bottom for the first fraction, 8 on the bottom for the second. And to be able to add these together, we need to put these in terms of a common denominator. Now the least common denominator for this pairing is going to be 8, since that is the smallest number that both 4 and 8 will go into. And if you notice, the second fraction is already in terms of the least common denominator. But in terms of adjusting the first fraction to get this in terms of eighths, while still keeping or preserving the value as being the equal of 3/4. So if I go from writing in terms of fourths to writing in terms of eighths, I can multiply this ratio by 1 in the form of how much 4 goes into 8 divided by itself. And in this particular case, 4 will go into 8 2 times. So I'm going to multiply by 1 in the form of 2 halves and 7/8. That already consists of the least common denominator. And for 3/4, if I multiply by 2 halves, 3 times 2 is 6. 4 times 2 is 8. So I have 6/8 plus 7/8. So it's going to turn out that for the result for 3/4 plus 7/8, this will come out to 13/8. And you can write as decimal like 1.625, or as a mixed number like 1 5/8, or just keep it as the fraction 3/8. Yes.
Where did the like the 2/2, where did that come from?
Okay, think of it like this. The 2/2. Okay, now 2/2, that is equal to 1, and I want to keep the value still equal to 3/4. So when I raise it to 6/8, 6/8 reduces to 3/4. But I wanted to make that I wanted to translate that 3/4 into a fraction where 8 is on the bottom. So in terms of how it got to 2/2, you're going to multiply by 1. Okay, and so now I could have, in other words, had the least common denominator been 16, 4 would go into 16 4 times, and this ratio would have been 4/4 otherwise. But the reason I'm going by 2 halves is that, okay, your bottom number is 4, 4 will go into 8 2 times. So I'm going 4 times 2, which is 8. And I'm going with 2/2 because I'm multiplying the first fraction by 1, because whatever change I make in the adjusted fraction, I want it to be still the equivalent. Like 6/8 goes back to 3/4, but I want it to be where I can add the numbers together. In fact, there should be 7/8 right here.
Okay, I get it.
Yeah.
Thank you.
In fact, as the next case, let's say you have letters involved. And let's say we have something like 5/2x squared y. And we have plus 3/4x y squared. Okay. Now if I'm looking at writing in terms of the least common denominator. Okay. Now it's kind of a different direction from taking the greatest common factor, like when we did the factoring by grouping. The greatest common factor would be like the highest term that would go into both of the sets of terms involved, whereas the least common multiple or the least common denominator will be where those respective terms will be the smallest amount, and those respective terms will go into. So we have with our denominators 2x squared y and 4xy squared. Now the least common denominator would be the smallest number, let's say starting with the numbers 2 and 4. The smallest number that both 2 and 4 will go into will be 4. And now for the letters x and y. Now for x, the smallest degree to which both x and x squared will go into, this will be x squared. And for y and y squared, that upon which y and y squared will go into, that is going to be y to the second. Okay. And since neither of these fractions consists of everything in the least common denominator, both of these are going to end up being adjusted. Okay. And say we have over here Okay, so we have with the first ratio. Okay, so you have 5 over 2x squared y. And I'm going to put this in terms of least common denominator. So I'm going to multiply by 1. So I'm going to have the same terms in both the numerator and denominator. Now, looking at what we have here, so I got the number 2. 2 into 4 will go 2 times. And x squared, we already have x squared will go into itself 1 time. Now for y, y goes into y squared, y times. Now for 3 over 4x, y squared. Okay. Now 4x, y squared relative to the least common denominator. Okay, there's a slight adjustment here. Now, we already had the number 4. Now, x will go into x squared, x times. And we already have y squared. And for what we have in terms of the follow through, okay, so you have, in this one case, you have 5 times 2y, so this will be 10y. And guess what? We got 4x squared, y squared. And we have plus 3 times x. And this is also over 4x squared, y squared. And we had the same denominator. Okay, so it's by then, if you saw the end result, you could have already written the final result. And you can write this in either of 2 ways. That is the order that you see them, like 10y plus 3x over 4x squared, y squared. And if you were to put this in alphabetical order, that's also an option. You could also write this as 3x plus 10y. All over 4x squared, y squared. All right, and just some items here. Tell you what, for the next few moments, let's see what we get. Let's say we have the first one. Let's say we have a difference of fractions. Let's say we have 3/10 minus 2/5. Let's say we have for the second, let's say that we have 5 over 2x y squared plus 7 all over x squared y. Okay, so for the next few moments, let's see what we get for the difference in the first and the sum in the second. If we look into these exercises, okay, so we have for the first, we have 3/10 minus 2/5. And between the fractions, okay, we already had the least common denominator present, okay, which is going to be at 10. So we already have with the first ratio, okay, we have already with 10 on the bottom. Okay, and for minus 2/5, if I adjust this fraction, so we have with 2/5, rewriting in terms of the denominator 10. Okay, so I multiply 2/5 by 1 in the form of the number of times that 5 will go into 10 divided by itself. Okay, so we're back to 2 halves. Okay, so this would be 3/10 minus, okay, we have 4/10. And it will follow that. We have 3/10 minus 4/10. Okay, so the result for 3/10 minus 2/5, this will be at negative 1/10. Now, for the sum of the fractions, 5 over 2xy squared and 7 over x squared y. Now for the least common denominator. Okay, so we got 2. And for x and x squared, okay, we have x squared. And for y and y squared, we have another y squared. And just taking what we have with the sum. And we have adjusting the first ratio. Okay, so we already have 2. Now we got x as opposed to x squared, and x into x squared goes x times. And we already have y squared. And for 7 over x squared y. Okay, so x squared y into 2x squared y squared. So we have 2. And x squared goes completely into itself, and y into y squared goes y times. And for what we have in the end result here, okay, now we're going to have the same common denominator. Okay, and for the numerators, we're going to have 5x. We got plus 7 times 2y, so it'll be 14y. Again, that's going to be all over 2x squared, y squared. Okay, and I'm going to sort of backpedal a bit. I noticed I had skipped number 91, but that's okay because it does kind of help just kind of redraw the difference between greatest common factor and least common multiple. And I was going to mention, just kind of going back to 91. So again, we have with factoring. Again, that was 50x cubed. Plus 160x squared y. And we have plus 128x y squared. Now for what we have among these terms, okay, now there is what's referred to as the greatest common factor, not least common multiple or least common denominator, but you're looking at the highest term that would go into all 3 of these. Now we got even number coefficients, and all of these have an x in common. And so we have here, for the initial factoring, okay, so we have 2x times the quantity of 25x squared plus 80xy plus 64y squared. Okay, so 2x is part of the mix, and the rest will come from factoring out the trinomial that we now have with 25x squared plus 80xy plus 64y squared. And re-entering the zone, okay, of the factoring by grouping. So again, we have with the first and the last coefficients, we have 25 and 64 multiplying together. Okay, so this will come out to 1600. And in the case of the factors of 1600, okay, we're looking at those that will add up to 80. Right now we have with 25 and 64, those will add up to 89. But for those that will add up to 80, okay, so you have 40 and 40. Okay, so you have 25x squared plus 40xy plus another 40xy. And we have plus 64y squared. Okay, so once again, grouping into pairs. Okay, so you have 25x squared plus 40xy. And we have plus the quantity. 40xy plus 64y squared and drawing out, okay, the respective greatest common factors. So into 25x squared and 40xy, okay, that's going to be 5x. And we have into 25x squared plus 40xy, that is going to be 5x plus 8y. And bringing down the plus, and the highest term that will go into these last two, that is going to be 8y. And that is also going to go 5x plus 8y times. So for the shared factor between the groups, you have 5x plus 8y. And the outside terms, once you combine, we have another 5x plus 8y. And for this result, okay, since this factor repeats, turns out that we have a square trinomial, whereupon this ends up as the square of the quantity of 5x plus 8y. So, looking at what we have here, okay, when we dealt with 50x cubed plus 160x squared plus 128xy squared, again, I took out the greatest common factor, which was at 2x. And so we have for the final result, okay, we have 2x, and we have times the quantity of 5x plus 8y raised to the second. Okay, so that would be the end result of what we have with number 91. Okay, so that was working with the greatest common factor to initiate the process, okay, prior to the factoring by grouping. Now, in terms of looking at combining ratios together, and let's say just as an instance, and this one a little bit tricky. I just want to use this as a final example here. If I have 3 over 8x cubed, y to the second, plus 1 over 24xy, and a half, plus 2 over 27 x to the fourth, y to the third. Okay, now if I'm looking for the least common denominator, so I have these various expressions in x and y. So we've got 8, 24, and 27. And now for the numbers, okay, see if I'm looking for the least common denominator, let me mention this. Now, this kind of goes back to, okay, to factoring, okay, and I know when I was like in elementary and to some extent middle school, like using factor trees, and the way they were done in the textbooks back then, it looks almost like play school in comparison to what's in the pre-calculus textbook, but there was a methodology to it. Now for the numbers 8, 24, and 27, like if I break down in terms of prime factors, like prime numbers are those counting numbers whose only factors that are positive will be 1 and the number itself. Okay, and like we have with 8, we have with factoring, this would be like 4 times 2. And 2 is a prime number, where factors would be 2 and 1. Now for 4 we'll go to 2 times 2. And so 8 is going to be 2 times 2 times 2. And for 24, you got 3 times 8. And guess what? 8 we already have is 2 times 2 times 2. So that'd be the prime factorization of 24. And as for 27, okay, like 27 would be 9 times 3. And 9 is 3 times 3. So 27 will be 3 times 3 times 3. So your prime factors in the mix will be 2 and 3. And of course, for the variable factors, we have the letters x and y. Now for the least common denominator, what you can do here, okay, is that with the numbers 2 and 3, and we're going to take the greatest representation of each of the factors. Like 2 does not appear at all from 27, but from 24 it appears 3 times, 8 it appears also 3 times. In other words, from either 8 or 24, 2 appears 3 times more than all the others. And as for 3 does not factor from 8, and it factors 1 time from 24, and it factors 3 times from 27. And for the letters x and y, you're taking the highest degree representation of x among the fractions. You have to the third, to the first, to the fourth. So you have x to the fourth, and for the highest degree representation of y among the 3 ratios, okay, it's going to be to the 3rd power. And for the least common denominator, so you got 8 and 27. So it'd be 216 x to the 4th and y to the 3rd. And just taking what we have among the fractions, looking at combining into an overall ratio. Okay, so In terms of the adjustments, I'm going to write these ratios in the form where we have this as the denominator. Okay. So just looking at raising stuff, I'd say 8 into 216. Okay, that's going to go 27 times. And x cubed into x to the fourth is x. And y squared into y cubed is going to be y. Okay, for 1 over 24xy. Okay, 24 will go into 216 9 times. X and x to the fourth will go x cubed times. And y into y cubed will go y squared times. And for 2 over 27, x to the fourth, y to the third. If I take 27 into 216, this will go 8 times. And we already have x to the fourth and y to the third. And since we're going to have the same denominator, again, so you have 216 x to the fourth, y to the third. As I multiply each set of denominators out and looking at what we have with the numerators. So you have 3 times 27 xy, so that would be 81 xy. Then for the next, I have plus 9x cubed, y to the second. And you have plus 2 times 8, which is going to be 16. Okay, so for the sum of these three ratios and writing in terms of least common denominator, okay, that is going to end up as the sum. And for this type of problem, I would say work is rather tedious. Okay, so in terms of the entertainment scale, probably ranks pretty low. But that is the process. If you were to look at it like in granular terms, looking for the least common denominator, looking at it all in terms of the prime factors, and this is going to be the end result in this case. And now, so we're still going to be looking at time and again working with factoring, and also look more into working with rational expressions and just items from your textbook to go ahead and be looking into. Again, just for practice, not to turn in. If there's anything to turn in, I will let you know in advance. And from page 51, okay, go ahead and be looking into numbers 17, 18, 28, 41, 43, 48, and also number 52.